Thank you very much. What's up, y'all? I'm Taylor. I'll be presenting our work on learning norms via natural language teachings, as he mentioned. Okay, so before I get into our particular approach, let's define what a norm is in our context. Traditionally, right, philosophers take a norm as an ought rule or an obligation. Kelsen, in his general theory of norms, took a position contrary to Kant that norms are obligations posed by other agents, right? So it requires an authority. And more recently, researchers have taken norms as a social instruction to perform or not perform a given action in a given context, given two conditions. The first being that enough people actually follow the instruction, right? The prevalence condition. And two being that enough people demand each other to follow the instruction, being the demand condition. But we follow another convention that distinguishes between two norm types, right? Because we don't always do things that we're obligated to do. We distinguish between what's called an injunctive norm and a descriptive norm. Injunctive norms are behaviors that are normative, which here's an example, like you should not cheat. And a descriptive norm is a behavior that happens often. So people often cheat. These two seem contradictory, but people can cheat and also think that other people should not cheat, right? We don't live in an optimal world. So with that being said, our representation considers 4 slots: the behavior that the norm is about, the contextual preconditions, the situation in which the norm is valid, right? The evaluation, the second dimension, the demand dimension, right? How permissible that behavior is, and then the prevalence, how often the behavior is observed. For each of these slots, the behavior and context are concepts grounded in concepts from our knowledge base NextKB. Evaluation is taken from one of the deontic qualitative values from the traditional threefold classification. And we also consider the second order operators of permissible, which is obligatory or optional. And you'll see, and omissible, you'll see an example here soon. And then prevalence is one of the qualitative values from this 5-valued qualitative scale, from always or continuously to never. And we represent norms in this knowledge frame-based structure. So here's an example of a representation for the act of cheating. And the behavior, let me get the laser pointer out. The behavior slot is filled with the act of cheating, right? And again, this concept is grounded in our knowledge base. And the context slot, in this case for cheating, this is a universal norm. So it's grounded in the concept location under specified, which in our knowledge base, right, is just the top most general location in the hierarchy. So this is a universal norm. In all context, cheating is seen as impermissible, right? Evaluation slots filled with impermissible. And thus this norm is an injunctive norm, the way that we defined it. Injunctive norms being norms that have an evaluation slot equal to obligatory or impermissible. And in this case, the prevalence is sometimes. Here's another example of a norm frame. In this case, this is a situated norm or a context-sensitive norm. So the act of reading in a library. Here, this shows the example of the second order deontic statics of permissible, the evaluation slot filled with permissible. So this would be like saying an agent does not know if reading in the library is something it should do or if it's optional, but it does know that it's not impermissible, right? And the prevalence in this case for reading in the library is it happens all the time. So, and thus, this is a descriptive norm. So, talked about the encoding for the norms, but we can't just hand encode these things, right? Because novel situations bring about new norms. Right now in the quarantine, we have things like mask wearing and social distancing, right? That were not a thing and even would have been strange. The evaluation would have been flipped like even a year or two ago. So agents, right, artificial agents, systems must learn these from multiple modalities as we do, right? Natural modalities. And we learn norms through things like instruction, through observing other people perform behaviors and then getting feedback, through by performing the behaviors ourselves and getting feedback, and then through secondhand experience. So a lot of the books that teach etiquette, they include stories, right, about people's cultures. And in this setting, norm learning here then is defined as tracking and combining evidence for that evaluation and prevalence slot of the norm frame. So given a behavior in a context, what the system is learning is what's the evaluation of that and how often does it happen? And we do this in combine evidence and represent evidence via Dempster-Schaeffer theory. So the strengths of using Dempster-Schaeffer theory in this context are that it does not require priors, right? It's not clear how we would obtain priors in this context. And you can explicitly represent a measure of reliability by representing this with a measure of ignorance, right? And this is important because an agent having false norms, false beliefs in norms can be detrimental. So being able to say, to discredit a given source of evidence for norms is powerful. And similarly, you can actually represent ambiguity because you can assign mass to sets of propositions rather than just singletons. This is important mostly for norms because the evidence you get while you're observing other agents perform actions and give feedback is highly obscure, right? So you need to be able to represent this ambiguity. So before I go into how we represent things with Dempster-Schaeffer theory and compute evidence, I'll define some terms. First, Dempster-Schaeffer considers a frame of discernment, which is just a set of all possible answers to a question, to the given question. Then it has mass assignments, which is just how much mass from 0 to 1 a given event provides for possible answers. And then you have belief and plausibility functions, which are the lower and upper limits of these confidence intervals after you combine mass. So to represent the frame of discernment, right, in this qualitative way, again, the frame of discernment is a set of all possible answers to a given question. And in this setting, the two questions are, what is the evaluation and what is the prevalence? Thus, the frame of discernment is all of the logical statements that are possible for the evaluation slot. In this case, it's the 3 qualitative deontic statuses, right? Similarly for prevalence, it's this set of all of the 5 qualitative values for prevalence from always to never. To represent mass assignments, we have this ternary predicate, and where the first argument is a reified event. So this could be something, in this case, for the act of cheating, right? This is the norm frame we're working with. This could be something like your friend saying, yeah, we should not cheat, right? And you can see here, the second argument is the subset of the frame of discernment that it yields evidence for. In this case, your friend is saying that it's impermissible. And the third argument is the amount of mass that this event provides for that subset of the frame of discernment. We default to 0.9 here just to leave a measure of distrust or leave a measure of ignorance. And here's another example, but for an event that yields evidence for the prevalence slot. So your friend could say something like, but we do cheat sometimes, right? So in this case, the prevalence is in the second argument. And then so the collection of all the evidence for statements for both the evaluation and prevalence slot are what we call a body of evidence, right? So all the experiences that an agent has had that yield evidence for these norms. Okay, we've talked about how we the representations and processes that we use underlying our system, but we really want to be able to, like I said, to have the agent be able to learn these from natural modalities. So we started with this question: how do we as humans communicate norms? For injunctive norms, right, we often just give evaluations via imperatives. They can be implicit. So in this case, whisper, right? This is an implicit evaluation. There's no actually saying, you're not saying you should, right? But it's a command. And then you mention some context along with it, right? So in the library. So this is a situated norm. Similarly, you can mention the context first, right? And then give an actual explicit evaluation. And then for descriptive norms, right, we give testimony of our own experiences or experiences from other people that we've heard from. We say things like people often read in the library, which provide a frequency of a behavior, and then again, mention of context. So we have these common semantic patterns for ways that we teach our kids or other social agents, right? So we're looking at these and saying, can we make a system that can learn from such natural language sentences? So given these sentences, our system first performs semantic parsing, right? And our parser CNLU results in predicate calculus semantics. Given these semantics, we perform feature extraction via abduction, which is just from the semantics extracting the relevant concept to fill in the norm frame slots. We do this through narrative functions, which in this context are, I guess, speech acts. So detecting if this sentence is actually providing a norm or giving evidence for a norm. And we compute the narrative functions via horn clause rules. And this process results in norm frame feature sets. From those feature sets, we then construct the norm frames, which get stored in the current logical environment for the discourse. And then from there, we merge evidence so that the agent can actually say, I believe X based on the evidence, right? And these result in belief theoretic norm frames, so we call. All right, so let's look at that those first two processes, going from natural language to parsing to semantics to then constructing a norm frame. I have an example of one narrative function here, introduces injunctive norm, right? So for a given sentence, right, a sentence is classified as an introduction of an injunctive norm if three other statements are proven, three other rules are proven. The first being that it provides an evaluation, right? And this statement is true if a relevant modal is found in the semantics, okay? And then case two is if it introduces a behavior, which is true if a relation between an action and a performer is found in the semantics. Similarly, for the introduces context, this statement is true if in the semantics there's some relation between that action that has been bound and where it occurs. So say the system got the sentence, you should not eat in the bathroom. Parse to semantics, right? We get the logical representation here of the semantics. We prove narrative function via abduction, so we assume introduces injunctive norm, which then runs R1, R2, and R3. So here, R1 provides evaluation, detects the not ought to do, okay? So it's found a relevant modal. First antecedent has been proven. R2 introduces behavior, detects the performed by relation, and introduces context, detects the event occurs at, right? So it has these rules that are mappings. Now, step three is to construct the norm frame with the variable bindings that result from this process. So provides evaluation. This has a ton of rules that do mappings from modals to the deontic status. So in this case, not ought to do, maps to impermissible. Introduces behavior, grabs the type, the action type of the eat1 variable, and context grabs the context type of bath1, and then substitutes that and fills the slots of the norm frame, right? So now we have this norm frame representation in the discourse. The agent possesses a logical environment for its beliefs. This norm frame is then stored in the beliefs, but the relevant slot, right, evaluation in this case, what it provided evidence for, is stored in this evidence for representation. Okay, and here's an example. Say that the system gets another statement, right? The brother, say that its brother says, you can eat in the bathroom. New norm frame introduced in the discourse, right? But it has the same behavior and context, eating event and bathroom, but a new evaluation. Once the plans run the storing, right? The storing process that goes from the norm frames in the discourse to the beliefs, it detects that a norm frame with the same context and behavior is already found in the beliefs. So it only stores the relevant new evidence. In this case being that the evaluation of that norm is optional. And here's an example of our system accumulating evidence as I teach it, right? In the first two cases, the system starts with no beliefs. So the first two cases, right, this is all new information. But when it gets to this third sentence, you should not eat on the bus, it's already heard something about eating on the bus, and it says that, right? And in this case, just like in the previous slide, it's only storing the new evidence, right? It's not just constructing a bunch of new norm frames, it's merging them and storing evidence. All right, so the agent now has a body of evidence, right? A bunch of norm frames with these evidence for statements. And now needs to be able to communicate its beliefs, right? Needs to be able to point to a situation and say, I believe that this is this prevalent, this has this evaluation. And we do this with two types of epistemic states represented in this logical form. So believes prevalence of behavior in context. So an example from my own experience, right? As an undergrad on the basketball team, we would often shoot in the gym, no matter if it was closed, right? So we would sometimes shoot in the gym, even when it was close. And this would be the representation of my epistemic state. I believe that shooting a basketball in a closed gym happens sometimes, right? And this epistemic state is computed when that lower limit of the confidence interval and the upper limit, the average between the two is greater than or equal to 0.9, right? So based on my body of evidence, I have enough evidence for the fact that this is my epistemic state and this is true. Analogously, we have the same epistemic state, but for evaluation. So from my experience, I believe that one should not shoot around in a closed gym, right? I've got a ton of feedback from other agents that I should not be doing this. Thus, I believe it's impermissible. However, I do think it happens sometimes. Similarly, this is true when the average of the belief and plausibility is greater than or equal to 0.9. So let's look at an example. Again, these are my beliefs as I've tried things, as I've encountered other people's natural language teachings, as they have instructed me. So this is the representation of my beliefs for shooting a basketball in a closed gym, right? 3 evidence events that yielded evidence. First is my mom telling me don't go shoot, the gym is closed, right? Second being the coach telling me do not shoot when it's closed. Third, while I'm shooting, the janitor yells at me, says get out. All yielding evidence for the fact that this norm is impermissible. By chaining Jems's rule, which I don't go into too much detail here, but essentially taking 2 mass assignments computes a third, right? And then you compute the belief and plausibility. And obviously in this case, the average of the belief and plausibility is going to be greater than or equal to 0.9 for impermissible. And thus, based on my experience, I believe that shooting a basketball in a closed gym is impermissible. So we can take bodies of evidence and now agents can say, this is what I believe, right? Here's an example of this happening again in our interaction manager interface. We created a few simple syntactic rules to map from natural language to those epistemic states that query the beliefs. The first for injunctive norms is what is your evaluation of, right? That just maps to believes evaluation of in behavior and context. So after training, I was asking it like, what's your evaluation of eating in the kitchen, right? And based on the training data, I believe that it was optional. And how often is someone eating in the kitchen? Based on the training data, I believe that it often happens. So not only can we train these things with natural language, we can also query them with some simple natural language queries. So rather than just simply typing at the system through the interaction manager, we wanted to test this approach on a small data set. So I gathered a data set of sentences that aim to teach norms. We looked at books on etiquette. So Emily Post and Catherine Flannery are big names in that field. And then I looked at posts on social norms and morals, just like from the web. Then also got a data set of noise. So these are just sentences that their main purpose is not to teach norms, like descriptive sentences. And these were drawn from simplified Wikipedia articles. This resulted in 235 training sentences in total, 100 being the positive sentences from the books on etiquette and posts on norms, and 135 being the negative sentences, right? The simplified Wikipedia sentences. Okay, so to test, we ran 2 different experiments. First, we were wondering if norm detection works, i.e., are narrative functions computed when they should, right? Are narrative functions, are speech acts detected on the actual sentence that do introduce norms? And then are narrative functions not computed on sentences that do not introduce norms, on the sentences from Wikipedia? And we got 100, we got perfect recall. So all of the sentences that actually did introduce norms the system computed narrative functions for. However, we received 4 false positives. So 4 of these sentences from Wikipedia had similar semantic structure. So they were similar to norm introductions. So there was 4 false positives. And then experiment 2, right? We know that the system can classify a sentence as being a norm introduction, right? As defined here. But we were wondering if the system can actually extract the correct concepts, right, that fill the norm from slots, extract the correct behavior, context, evaluation, prevalence, and then store the correct evidence statement and combine the belief in a way that yields beliefs that's indicative of the training data set. So does the system believe what it should believe after it's trained? So we labeled each positive data point with a respective query and the expected label. So example from the training data set was people often sing at recitals, right? And then given the natural language query, how often is someone singing at a recital? It should respond with often, right? If this is the only training data point about recitals, singing at recitals. We then trained it and then obviously ran each of these queries. And we received 100% query accuracy on this data set. So for these types of norm introductions, for these type of speech acts, the system can not only detect and classify a sentence as being a norm introduction, but also learn from those norm introductions and answer these simple natural language queries. And here's some examples from the training data set and then the model's output. So that top example illustrates the second order deontic status being computed. So to training sentences where you can eat in the kitchen and you should, right? So there's conflicting evidence, one saying that's optional, one saying that you must do it. And then based on the query, it's saying that it's permissible, right? It does not know, it cannot distinguish, it does not know for sure which one of these it should, if it should do it or if it's optional, but it does know that it's not impermissible based on the training data. And then there's some other cool examples in there too. Crying at funerals, talking in elevators. Yeah, we rarely do that. At this point, I should mention some related work. The use of computing narrative functions to extract things from natural language is directly inspired by work on extracting QP frame information by McFate and others, right? But we're extending this to work on detecting norm introductions and extracting norms. And then the use of Dempster-Schaefer for learning, specifically for norms, is inspired by Serthi and others' work on learning norms from questionnaires. But we extend this work by going from natural language teachings and also to natural language queries. So shout out to them. I'll wrap up here with some future work, planned future work. The norm extraction process, obviously for the rules, I had to look at the semantics, right, after training after running the parser on some of the natural language training sentences, and then look for common semantic patterns, which is obviously not feasible. It's not going to be, it's not going to scale. So we're going to be looking at learning these rules automatically, right? And then looking at stories, both learning them from stories, so action feedback pairs, right? A character performing a behavior and then their parent or their friends responding in some way, and then using those learned norms to evaluate characters and stories. So you can imagine the system, after it's learned some norms, labeling characters as protagonists or antagonists based on how much they go contrary to norms, and then using that to do some story understanding and prediction. And lastly, grounding these norms in prescriptive theories. So our system and other norm learning systems, they start with no like normative basis, right? So I could teach it any outlandish thing. I could teach it that it's okay to harm somebody. So we're looking at starting the system with some prescriptive theory to start with that allows the system to evaluate the norms that it's learning. So that's all I have. Here's some references for things that people are interested in. I appreciate you all for your time and thank you for coming.
Excellent presentation and excellent timing, Taylor. Thank you very much. So we have a number of questions because of the interest on this presentation. I'm going to go one by one in order. The first one is by Irina Rabkina. She's asking, are you planning on incorporating the truthworthiness of the source into your model? To use your example, we might want to trust a parent who says that it's impermissible to eat in the bathroom more than a brother who says that it's fine.
Yeah, absolutely. Not only the relation of the agent that's giving the evidence, but once the system accumulates enough evidence, you can imagine the system discrediting people that are going against its beliefs. So once the system has enough beliefs, right, once it's been trained enough, if if you get like people saying it's like you should not wear a mask or something, and you've been trained a lot, you can just start to discredit their evidence, right? So all their mass is going to be really low. So not only the relation of the agent, but also once the system has enough beliefs, it can also discredit that based on if it's going against its internal beliefs.
Thank you. We have the next question is by Clifton McFade. He's asking that the patterns you describe, while x, comma y, etc., seems to have consistent syntactic features, especially around models. It looks like you're using the semantic interpretation of these structures for narrative functions such as DRS nesting. Is there a lot of variance on the structures people use to express norms and values? To what extent can you use syntactic structure difference directly to draw conclusions?
Involved question. So I think in this work, right, the sentences that we use, like you're hinting at, they do have common syntactic features, but I think there's a lot of variance in the structures that people use actually to express norms, right? So this is just a small set. I'm considering I guess deontic declarations, commands, and then explicit prevalence, which have common syntactic and semantic structures. But there's going to be a lot of variance when we consider other types of things. And I plan to explore that later. I don't have much to say on it now, but obviously exploring more involved ways that people norm, right? So even across sentences too, you can imagine in stories, you're going to have to pick out the context from one sentence or multiple sentences, and then the behavior from another sentence. So you're going to have to piece this together. So it's a good question. I don't have a full answer for that now, but yes, of course, there's going to be more semantic variance as I consider more types of things.
The next question says, from examples, how does it decide rarely, often, frequently?
How does it decide rarely, often, frequently?
Yeah, I guess from the few examples, I'm interpreting that question that way.
Yeah. So in this setting, we are only considered with explicit mentions of frequencies. So if somebody explicitly says often, right, then it maps directly to often. But as we consider more sophisticated ways that you might mention the frequency of things, handling that mapping, right, sometimes it could be arbitrary. Like if you said infrequently, is that rarely or never? Or it's like mapping these statements that we say in language to the qualitative scale is going to be something we're going to have to explore. But here we're just considering, we're going with the mappings that we have in our language system. And most often it's just explicitly saying often and mapping to often.
So I was thinking of a case like they told you to get out of the gym. What that would be an example of a single instance. And then how do you combine that with other evidence to decide whether that's...
So in that case, that's yielding evidence for the evaluation.
Right.
There's no prevalence statement introduced.
Okay.
They're saying that it's impermissible.
Yeah. But so then if you only had seen people playing in the gym once, how would you deal with that?
If you had only seen people playing in the gym once, I guess if you've only seen people playing in the gym once, are we assuming that you've only been in the gym once? So it's like the frequency of shooting around in correlation to how many times you've been in the gym, I guess.
Right. I mean, that's kind of the question is, how do you go from specific instances to general statements?
Yeah. This is a huge thing. I didn't mention this in the future work, but I guess trying to tell me if this is wrong, but how I frame this is you're combining your firsthand experience, right, with people's secondhand experience. Because right now this is secondhand experience. You're going from people's instructions and testimony, right? Now, how do you combine that with your actually experience, right? Because that's probably, it could be just statistical. You could represent that as it's 50% of the time. Now, how do you combine that with that representation? And that's a question that I still have yet to answer, but it's definitely going to be important for future work.
Okay, great, thanks.
Okay, the last question is by Justin Lee. The question is, the occurrence estimation seems to be general for example, as a generic estimate of probability of something happening? Is there something that makes it specific to norms, or do you see it as a generic capability that could be used by other parts of a cognitive system?
I don't think I have a great answer for this, but I don't think it would be specific to norms. I do think it could be used in other parts of a cognitive system, but I don't have much more to say on that. It's a good question, but I'll have to look at that more in detail after, offline.
Thank you, Taylor. That was great presentation.
Thank you. I appreciate it.